Dear students, welcome to my lecture. Myself, Dr. R. Arulprakasam, Associate Professor, Department of Mathematics, SRM Social Science and Technology. Today lecture I am going to discuss Cauchy residue theorem. Cauchy residue theorem. So before going the statement of Cauchy residue theorem, so what is the meaning of residue? So first you should understand definition of a residue. So what is the residue? So just I am writing the definition of residue. Let Z is equal to A is a complex point. B, an isolated singular point, isolated singular point, isolated singular point of the function complex function f of z. The coefficient b1 of the function of z minus a whole power minus 1 in the Lorentz series expansion, the Lorentz series expansion of the function f of z about a about a point about a point A is called the residue of f of z. Residue of f of z at z is equal to A. Generally, it is denoted by b1 is equal to or residue of the function f of z, residue of the function f of z at a point A. Otherwise also denoted by residue of A. It is definition. What is the meaning of residue? Residue, a point, is the isolated singular point of the function f of z. The coefficient, here I mentioned the coefficient of the, in the Lorentz series expansion, last class we discussed what is Lorentz series expansion of the function and the Taylor series of the expansion function. The Lorentz series expansion, we have two parts. One is principal part and the regular part we discussed already. So in the negative power z minus a whole power minus 1 coefficient value is b1. The coefficient value is called the residue of the function f of z at a point z equal to a. So generally it is denoted by residue in the Lorentz series expansion coefficient of z minus a whole power minus 1 or 1 divided by z minus a coefficient value of is called the residue. It is denoted by b1 or residue of a and the residue of the function f of z at about the point a. This is definition. So next I'll move on. What are the methods of finding residue? So now I'll move on methods for finding residues. So I have the four formula. First one, suppose if if suppose if z is equal to a, if z is equal to a is a simple pole, is a simple pole, then residue of at a point a is nothing but formula limit z tends to a z minus a into f of z. It is first form. Suppose we have the simple pole, Then the residue formula nothing but limit z tends to a, z minus a into f of z. What is the second? Suppose pole of order m. I'll explain detailedly solving the problem. Just I'm writing the formulas how to find residue. Suppose if z is equal to a is a pole of order is a pole of order m. Okay. Then what is the formula for residue? The residue of a at a point a about the point a nothing but 1 divided by m minus 1 factorial limit z tends to a d power m minus 1 divided by dz power m minus 1 into z minus a whole power m into f of z. It is second type of the residue formula. Also, we have one more method of is there for finding residue. The third one is suppose if A is a simple pole, is a simple pole for the function f of z, and the condition is given, and if f of z is of the form h of z divided by k of z, where h of z and k of z, where h of z and k of z are analytic at a point a, at a point a, and also the h of a not equal to 0, k of a value 0, then the residue of a nothing but h of a divided by k dash of a. That is definition for method for finding residue. So now I have three methods finding residue. One is simple pole is given. Here is simply mentioned simple pole is given. So what is the formula for finding residue? The simple pole residue formula nothing but limit z tends to a z minus a into f of z. Suppose I have pole of order m. So formula nothing but here I mentioned residue of in pole of order m given now. So 1 divided by m minus 1 factorial limit z tends to a d power m minus 1 dz power m minus 1 nothing but z m minus 1 time derivative with respect to z. So into z minus a whole power m into f of z. And third one is suppose I have the function f of z. Here I simply mention I have the function f of z in the form of h of z factor form h of z k of z. So the condition is given h of z and k of z, h of z and k of z are analytic at a point a, and also h of a not equal 0 and k of a value 0 means then residue of directly I can substitute residue of a about the point a nothing but h of a divided by h days of a. What do you mean by h days of a? One time differentiation with respect to z. That's it. Only three methods we have for finding residue. So now I'll move on some simple problem how to find residue value. So followed by one we'll go. Suppose I have the function find the residue of the function. First problem, find the residue Find the residue of the function f of z is equal to e to the power z divided by z square. So in the first, what is the definition I mentioned? What do you mean by residue? Residue is nothing but, you know very well, residue is nothing but in the Lorentz series expansion 1 divided by z minus a coefficient b1 is nothing but coefficient of 1 divided by z minus a in the Lorentz series expansion of the expansion of function f of z about the point A. This is the definition. By the definition, I am explaining one problem. Then later I'll go for three method of definition, a method of formula I mentioned, followed by the formula how to find the residue. So first we should express the last class I explained how to express the series expansion. Suppose here I have mentioned the function e to the power z divided by z square. Just expanding the series representation, you know what e power z series expansion, you know e power x is nothing but 1 plus x by 1 factorial plus x square by 2 factorial. It's in the real function. Here complex function is given. So followed by the e power z, we can express the series representation of the function e to the power z. So I have 1 plus z divided by 1 factorial z square divided by 2 factorial, it will go on up to infinity. So here in the numerator side I have the function, in the denominator side I have z square. So just to simplify the function equation, what happened 1 by z square plus z z divided by 1 factorial z square, and what happened here 1 divided by z by 1 factorial value nothing but 1. Simply I can write 1 factorial plus, what about here? Z square cancel. So what happened here? 1 divided by 2 factorial. So next, just what is the next step I am getting? Z cube by 3 factorial. Here I am getting Z divided by 3 factorial. Then Z square divided by 4 factorial. It will go like that. Yes. Yes. So now I have to discuss what is the regular part and principal part. The regular part is nothing but positive part. Just we can separate. It is the beauty of the in the Lorentz expansion. We have to separate it. What is the positive power and negative power? So these are all positive power. Suppose I have to include one more term here. Z square divided by, so z power 4 means cancelled. Z square, I am getting z square divided by per factorial. Based on this, what are the positive power? Here 1 divided by 2 factorial plus z by 3 factorial plus z square divided by 4 factorial, followed it will come some infinite term. This positive power because of there is no negative form. So always positive. Plus what are the negative power I have? 1 divided by z plus 1 divided by z square. Yes. What is the definition of residue? My residue is nothing but about here. What is the singular points? So my singular point is about the point z is equal to 0. About the point. So 1 divided by z minus 0 coefficient value. Here 1 z minus 0 coefficient value. What is the answer I am getting? My answer is to the coefficient value 1. Therefore my residue b1 value nothing but 1. That is followed by the definition of residue. Understand this? So here function is given. So just to express the series representation, here Lorentz series expansion. What do you mean by Lorentz series expansion? Positive power and negative power. The negative power z minus 0 coefficient is b1. My b1 value 1. So this is our residue of the function about the point 0. That's it. This is one problem by using the definition. Now I'll move on second problem. So what is the second problem? I am going to followed by the formulas. So first I move on problem. Find the residue of the function. Find the residue of the function f of z is equal to z plus 1 divided by z square minus 2z. Okay. So here problem is given. So what we'll do? First, what is the function? Just I'm taking my function f of z nothing but z plus 1 divided by z square minus 2z. So first step to find poles of the function. To find out poles of function f of z. How to find the poles? The denominator equal to 0. I am getting the poles z square minus 2z equal to 0. I have take commonly z outside. Z minus 2 equal to 0. I am getting z is equal to 0 and z is equal to 2. I have two poles or singular points. Two simple poles. Okay, singular points or poles. So I have what is the order? My order is always 1. Therefore, here z is equal to 0 and z equal to 2 are simple pole. Why it is simple pole? Because order is 1. Suppose I have the function z minus, for example, suppose I have the problem here, square is there now. Here 0 is simple pole because of power 1 and here power 2, so it is pole of order 2. Okay, this is the one. So here I am taking given problem on a simple pole. So what is the next? How to find residue of the function? How to find residue of the function followed by the given method. So what you know the formula? Simple pole residue formula. What do you mean by simple pole residue formula? What is our simple pole residue formula? Simple pole residue formula. What is the formula? So I know residue of A, just write out the formula, limit z tends to A, z minus A into f of z. It is for simple pole residue formula. By the formula or by the method, I am getting the residue of the function about the point 1, 0 and 2. First, I am move on how to find residue at a point 0 first. Residue at a point 0, 1 second. The residue at a point 0. Some textbook denoted by like this, some textbook the residue of the function about the point 0, otherwise denoted by P1. It is any one various notation we can use. Generally I am using residue of 0, first one. How to find residue about the point 0. What is the formula I mentioned? Limit z tends to 0 into z minus 0 into f of z. Limit z tends to 0, z into, what is our f of z? My f of z here mentioned z plus 1 divided by z into z minus 2. See, here I simplify now. So otherwise I can write z plus 1, z into z minus 2 like this. So here what happened here, z cancelled, simply substitute instead of z to 0 I am getting the answer. So here I am substituting instead of z to 0 I am getting here 0, here 0. What is the answer I am getting? My answer is nothing but 1 divided by 2. Here 1 divided, here minus 1 nothing but cancel, minus. Okay, one second. Here my question z plus 1. So I am taking the problem here z plus 1, here minus 2. So nothing but minus 1 by 2. My residue value, residue of 0 is nothing but minus 1 by 2. Similar way I am doing second residue as second poles residue value. So just refine the residue of 2. What is the residue of 2? Just I can write like this. Residue at a point 2, or I can denote it by residue of the function f of z at a point 2. Whatever it is, we can use any one notation. So what is the formula? My formula is limit z tends to 2, here z minus 2 into in the function f of z. What is our my f of z? My f of z nothing but z plus, directly I am writing the function formula, because already you know the formula, by that's so that I am writing z into z minus 2. So just I am eliminating z minus 2, z minus 2. Now substitute instead of z to 2, what happened here? Instead of z to 2, I am substituting here 2, here 2. My answer is 3 by 2, right? 2 plus 1, 3. So here 2, 3 by 2. So it is first method for finding residue at a point, at a simple pole z equal 0 and z equal 2. So next I move on one more problem based on this, how to find residue value in pole of order m. So just take third problem. So just find the residue find the residue find residue of the function f of z is equal to z plus 2 divided by z plus 1 whole square. So same method we can follow. First, what is the function? My solution we can solve like this. Take what is my function? My function f of z is equal to z plus 2 divided by z plus 1 whole square. First step to find poles of the function, poles of f of z. What is my poles? So already I mentioned how to find poles. So in the function equating denominator equal to 0. So z plus 1 equal to 0. So I'm taking here z is equal to minus 1. Here the power is 2. Therefore my poles is here minus 1. This pole of order 2. Pole of order 2. Got it? Suppose here power 1, it is pole of order 1. So here pole of order is 2. Just take it. Pole of order 2. Okay. So you know immediately we should come to in our mind what is the pole of order 2 residue formula. My residue formula pole of order m. What is the pole of order? Pole of order m residue formula. My residue formula nothing but 1 divided by m minus 1 factorial limit z tends to a d power m minus 1 divided by d z power m minus 1 z minus a whole power m into f of z. It is pole of order m residue formula. We know very well. We know that. Followed by this, I am solving this problem. So find residue at a pole of order here m value 2. So look at this formula here, yeah, order m value 2 here mentioned, right? My pole is minus 1. So just to find out pole of order m equal to 2 and residue formula r of minus 1. Just write out the formula. So 1 divided by 2 minus 1 factorial limit z tends to minus 1, okay, into d power m minus 1, 2 minus 1 nothing but just d divided by dz into z plus 1 whole square into f of z, right? Okay. Now 1 divided by 2 minus 1 factorial nothing but 1 by 1 factorial limit z tends to minus 1 d divided by dz of, so z plus 1 whole square into what is our f of z? My f of z nothing but z plus 2 divided by z plus 1 whole square. So here z plus 1 whole square, z plus 1 whole square cancel. So 1 divided by 1 factorial nothing but 1. So limit z tends to minus 1. So d divided by dz of z plus 2. What is the meaning? It is one time differentiation with respect to z. So my answer is limit z tends to minus 1. So differentiation value 1, the constant differentiation value 0. See here, the differentiation with respect to z, answer 1. So constant differentiation value 0. So my answer is there is no z term, so answer 1. Therefore, my residue of pole of residue at a point minus 1 is a pole of order 2, residue value nothing but 1. This is second method. Any doubt? Okay, now I'll move on one more problem. How to find residue value? Both cases applicable. So third problem, I think fourth problem, right? So now find residue of the function f of z is equal to z plus 2 divided by z plus 1 whole square into z minus 2. So similar method, what is the problem here? Solution. Here I have to mention both method within the one problem. It's a simple pole, here pole of order 2, right? So what is the function here mentioned? My function f of z nothing but z plus 2 divided by z plus 1 whole square into z minus 2. Okay, first step to find poles of function f of z. What is my poles? So already mentioned equating denominator equal to 0. So z plus 1 whole square into z minus 2 equal to 0. Therefore I have two poles. Z equal to 2 is a simple pole. Why? Because here degree 1, I mean power 1. Next one is z is equal to minus 1. Here pole of order 2. Okay. Next, how to find residue? It is using the simple pole formula. I am getting using simple pole residue formula. I am getting this residue value. Here using the pole of order 2, I am getting residue value. Right. So now first I can move on. First one to find residue at a point 2. Here 2 is simple pole or pole of order 2. Here 2 is simple pole. So you know the formula. Directly I am writing this answer. So simple pole formula, you know, limit z tends to 2, right? Z minus a into f of z. What is my f of z? Z plus 2 divided by z plus 1 whole square into z minus 2. So I am eliminating z minus 2 cancel and substitute whenever we have z to 2 because of here z to 2 here mentioned. Here 2. So what is the answer I am getting? So my answer is, so here 2 means 4, here 2 means 2 1, 2 plus 1 3, 3 square nothing but 4 by 9. It is for residue at a simple pole at a simple pole z equal to a. So next, what is the next? My next question is find the residue at a pole of order 2. Residue value at a point z equal to minus 1, it is a pole of order 2. So what, directly I can write the formula. So you know pole of order m, you know the formula, here m value 2. So by the followed this one, I am writing directly answer 2 minus 1 factorial d power limit z tends to 1, right? Sorry, z tends to minus 1 into d divided by dz of z plus 1 whole square into f of z. What is my f of z? So my f of z nothing but z into, sorry, z plus 2 divided by z minus 2. One second. Z plus 1 whole square into z minus 2. So here cancelled. So next, what happened here? Cancel means I am getting 1 divided by 2 minus 1 factor nothing but 1. So limit z tends to minus 1. So d divided by dz of, so z plus 2, one second, z plus 2 divided by z minus 2. So what is the meaning of? It is one time differentiation and then substitute limit value. What is the differentiation? Limit z tends to minus 1. So by u, you know the formula, u by v formula. So v square z minus 2 whole square, right? So z minus 2 v square v into u dash. So z differentiation value 1, the value 0. Constant differential by the formula minus, so z plus 2, z minus 2, z plus 2, that v differentiation value 1 minus 0. Now I can substitute whenever we have z2 replaced to minus 1. So what is the answer I am getting? My answer is, here I am substituting minus 1, here I am getting minus 1, here I am getting minus 1. So answer is minus 3. So I am writing here minus 3. So what about here? Minus, here plus 1. So I am getting minus of 1 divided by, here what happened here? Minus 3 nothing, minus 1, minus 2 nothing but minus 3 whole square. So my answer is, therefore my residue of minus 1 nothing but C minus 3, here minus 1, minus 4 divided by minus 3 whole square divided nothing but 9. This is for residue for minus 4 pi d. So uh, in this class I explained what is residue. I am giving the outline of this entire lecture. So I have defined what is the residue. Residue nothing but what? So in the Lorentz series expansion, negative power I 1 divided by z minus a whole, 1 divided by z minus a, or z minus a whole power minus 1 coefficient value b1 is residue, right? Next, what are the methods we have to find the residue? Three method I have mentioned. One is simple pole. Simple pole is there, then how to find residue. Polar order m is given, how to find the residue. And suppose function f of z, we have the form h of z divided by k of z. That problem I will explain later. Okay. So follow the three method of problem I discussed. In the Lorentz series expansion, how to get the residue value. Simple pole is given, how to find the residue value. Polar order m is given, how to residue value. Both is combined within the one problem explained. Thank you, students. We'll see next class, residue theorem problem.